In this lesson, we're going to talk about two word problems that are in standard form. Example 1. A football is punted and its path is modeled by this, where h is the height of the ball in yards and d is the horizontal distance in yards traveled by the ball. Really important when you read word problems that you determine what everything stands for. What does d stand for and what does h stand for? It makes answering all the questions a lot easier. So h is the height of the ball and d is the distance it's traveled horizontally. So here's the graph. So this is your horizontal distance right here, meaning, and so imagine this being on a football field, meaning at about 15 yards. So someone has kicked the ball here at about 15 yards. This is my h-axis, so this is the height of the ball. What is the height of the ball? What is the height that the ball is kicked from? It's too hard to tell from the graph, so we'll calculate the h-intercept. When it almost looks like 0, 0 right here. So when the ball is kicked, our horizontal distance is 0. So there's no horizontal distance. This is the beginning of this modeling here. There's no horizontal distance. So what is the height when there's no horizontal distance yet? We're going to sub in d equals 0 into our equation here. So here's our equation we're given. The d's are here and here. This is a really easy calculation. Sub in 0. 0 squared is 0. That's going to turn this piece to a 0, and that's going to turn this piece to a 0. We end up with 0.75, and you'll notice that was the C value. I didn't even have to do this calculation right here. When I'm looking for the h-intercept, or whatever your vertical is, normally we call it a y-intercept, but in this case it's h. When you're looking for the vertical intercept, all you need to do is look for the constant. Whatever the constant is, that's going to be your answer, because everything else is going to turn to 0, right? We subbed zeros in all this stuff, they all turn to 0, so I didn't even need to do this. I know the answer is going to be 0.75. So, important part of this type of math that we're doing right now, word problems, is what does this number mean? What did we find out here? You always need a therefore sentence at the end of any word problem. Therefore, the ball is kicked from an initial height of 0.75 yards. So that's a distance, a vertical distance. That's an imperial measurement. A lot of our questions are usually in metric, and we might say meters or something here, but this particular question is in yards because football usually is. So it didn't start right at the height didn't start right at the bottom. B, what is the maximum height reached by the ball? So let's think about this. The maximum height reached by the ball. Well, we have a graph right here to look at. So we're looking at the vertex. Anytime you see the word maximum or minimum, right away you think vertex. Since the vertex is at 2532, that means the maximum height is, so which one of these two numbers? How many yards above the ground? Which one of these two tells you the maximum height? Is it 25 yards above the ground, or is it 32 yards above the ground? Which one is it? Well, look at the coordinate here. Normally we would say the first number is an x and the second number is a y, but this question has different variables. This is normally where our x would be. So instead of an x, this 25 is actually the d, and normally our y is right here. So this is h. So now I know what the variable, what letters are represented by what variables. I'm looking for the maximum height. So I'm looking for the h value there. So the maximum height is 32. That's the answer for that one here. Part C, at what horizontal distance, so how far down the field, is this maximum achieved? So this is your field down here, and this is your football going up and coming back down again. So how far along, after it's been kicked, how far along is the maximum achieved? So again, it's one of these two numbers here. Again, the vertex is at 2532. So that means the maximum height is achieved when the football is how many yards across the field? So this time we're looking for the distance, the horizontal distance, that's 25 number here. So we're going to put 25 on this space here. 25 yards across the field. Last part of this question, what does 50.30 represent? So I've got another coordinate here. What does it represent? So remember what the letters are. Let me label them again. My first letter is the D, and my second letter is the H. So we've got a D of 50.3, and we've got an H of 0. I don't know why I'm showing a negative 0 there. 50.30 means that 50.3 yards horizontally, the ball's height above the ground is 0 yards. So 50.30 is an x-intercept. Of course, we're using D here, a D-intercept, and it represents when the football landed on the ground. That's what it's really stating there. It represents when the football landed on the ground. It's an x-intercept or a D-intercept in this case. With this question, all it was about was you had an equation in standard form, so it's not factored, there's no brackets here. We had an equation in standard form, and we were just pulled out a bunch of information from this question by looking at the graph, by using the vertex. Here we didn't even use the graph, we used the equation, we got the constant there. So all this question is about is what can you tell me about this graph just from the equation and a few points on the graph, and you could tell me quite a lot. Example 2. Model rocket is launched from a platform. Its flight path can be modeled by this relation here, where h represents the height of the rocket, usually that's what your h is, and t usually represents time, and it does here. This is time in seconds. Without creating a table of values and then graphing, answer the following questions. So we have no graph this time, but we have to answer these questions without a graph to look at. What is the height of the platform? What is the height of the platform? So I'm looking for an h value. What I need to know is when is the rocket on the platform? Well, the rocket is on the platform at the very beginning. Since the rocket is sitting on the platform at the beginning, then we need to look for the height at time 0. So we're looking for the height at time 0. So I'm going to take my equation, which is h equals negative 4.9 t squared plus 100 t plus 13, and I'm looking for time 0. So I don't even need to do this line that I'm doing right here. Remember what I told you in the last slide? That once you sub in all these zeros, all you're going to be left with, 13, is your constant, that number there. So the height of the platform, therefore the platform, and what units are we using here? 13 what? Is 13 meters high. So that's where our rocket is starting from. And I didn't need to even do this. I could have just gone right to the equation. As soon as I realize what I'm looking for is time 0, as soon as I realize I'm looking for initial height, then I could just go right to the constant there. Part B, does the parabola open up or down? Will it be narrow, wide, or normal width? Do you remember how we tell that? What are we looking at in this equation? We're looking at the a value. That will tell us this. So the a value is negative 4.9. So a negative a value means it's going to open down because of the negative. And the number part tells us if it's going to be narrow, wide, or normal width. So a 4.9, remember if you have a number that's bigger than 1, means it's a vertical stretch. So a vertical stretch means it's going to be narrow. So it's going to be narrow and it opens down. It opens down because the vertex is at the top. So it would be a parabola like this. The vertex is at the top because of the negative a value, so it opens down. Part C, the coordinate of the vertex is 10.2, 523.2. Explain what the vertex means using the terms of the word problem. Is the vertex a maximum or minimum? We already talked about that, right? The vertex over here, we already know if it's a maximum or minimum, but let's take this one step at a time. This number right here is the t value of the coordinate. Remember, normally we use x and y, but I have to look up at my equation and I see that in the place of where normally we would have an x, we have a t. So this is, first number is t and the second number is h. The first number is the t value of the coordinate. The second number is the h value of the coordinate. So what does the vertex mean? If we have a t of 10.2 and an h of 532.2, what does that mean? It means at 10.2 seconds, the rocket will be where? Where's the rocket going to be? What's the height of the rocket going to be? It's going to be 523.2 meters high. That's what the vertex means. And this is important here. It says using the terms of the word problem. So I can't just say here the vertex means the highest point, or the vertex means, you know, a maximum. We have to actually explain what the words refer to. Second part of the question says, is the vertex the maximum or the minimum? Remember that we already know it opens down because of the negative in front. So if it opens down like this, we know the vertex must be the maximum value. The vertex is the maximum. What is the height of the model rocket after 7 seconds? You notice in these questions, we're not doing a lot of math. We haven't done a lot of math yet. We're just working hard at interpreting what these numbers mean. Let me erase this stuff here. Interpreting what the constant means, that 13, what the a value means, that's what we're kind of focusing on so far. We want to know what the height of the model rocket is after 7 seconds. So what is this number? Is this number a t or an h number? 7 seconds. Does it represent height or does it represent time? Well, it represents time. So we need to find h. We need to find the h value. We're looking for the height. What is the height? So we need to find h when t equals 7. So that's me taking this sentence right here and rearranging it into some math, closer to math anyway. So I'm looking to find h when t equals 7. So I take my equation and I'm going to sub in. Let me take a color here. How about green? I'm going to sub in t equals 7. H equals negative 4.9, 7 squared plus 100 times 7 plus 13. So here's where you get out your calculator. Remember the order of operations. We have to do the 7 squared first. That's a 49. Let me write that out for you. So that the first step must be 7 times 7. And then I can go on and do the rest of the question. Okay, so I want you to press pause, get your calculator, and get the answer yourself. Okay, let's think about this number. Does this make sense? So we're looking for the height at 7 seconds. So what we have here is at 7 seconds, h, or height, equals 472.9. Does that seem reasonable? Well, let's look at what we had here. The vertex, which is the highest point, is at 10.2 seconds. And that's at 500, that will be a height of 523.2. So yeah, I think this is a good number. This looks reasonable because at 7 seconds, we're not that high. I would be concerned if this number was bigger than this. I already know this is the vertex. The question told me this is the vertex. So if I got a really big number, I would know what's wrong. Also, if I got a negative, I would know what's wrong because at 7 seconds, we certainly can't have a negative height. So let's make a sentence to go along with this. Therefore, at 7 seconds, the model rocket is 472.9 meters high. Last one. Explain what this coordinate represents. Again, all this stuff is about, do you understand the standard form of a quadratic, and do you understand what all of it means in a word problem? You've got 20.5 and 0. Important that you point out to yourself what those numbers, what letter they represent. The first number, remember, is the t value of the coordinate. It's the t value because it's normally our x's first, but instead of an x up here in this equation, we have a t. That's how I know the first number is a t instead of our usual x. The second number is usually a y, but for us it's an h because that's the letter that's over here. So now I know that this is a time number and this is a height number. I can come up with an answer to the question. What does this coordinate represent? So it's at time 20.5 seconds, the height is 0. So what does that really mean? The height is 0. That means, just like the football question, that means the model rocket is back down on the ground if the height is 0. This coordinate represents the t-intercept as opposed to the x-intercept. It's a t-intercept, and that the rocket lands at 20.5 seconds. Everything we've done today is interpreting a word problem in standard form and trying to draw out as much information as we can and to understand how the variables, the independent and the dependent variables, are used to answer the word problem.